rotate or move that axis only. Beyond that, that robot will indicate an axis limit error over and which we can be able to not be able to move the robot. At the beginning, I have shared the feature of the robot. What should be the feature? In that feature, I have told you that it should have a vision and sensing device to fit it on it. Here you can see the collision detector. Whenever it comes in contact or collide with any kind of work or any kind of object, it will stop immediately and create an alarm of collision detection, which means it observes or it sends more force than it actually faces during normal activity. To eliminate this, we have to remove that force from the robot, then we have to move it manually, and again we will restore it for automatic running. Now I will come to the programming structure of the FANUC robot. That might be a different for different robots, for different manufacturers. But if we can be able to understand this programming syntax, then almost similar kind of program you guys will be able to see in a later part of your career. Here you can see this is a line number, this is a type of motion format in which you want to move the robot. This is a point data. Each and every point has 6 different coordinates. Here you can see the P1, which means the point 1. The data is stored into the robot for the point 1. If we move the robot to P1, it will move to that specified coordinates. And here you can see that 2 different types of 100% or millimeter per second. This is a feed rate, at which speed we want to move the robot, and this is a fine and continuous. How we want to move the robot, in which path. This is a positioning path. For example, if we move the robot in a straight line, then we will select a fine. Then if we want to move the robot in a curved path or a continuous motion, then it should be selected in a CNT. You can see here another example. Line number 1, the motion instruction is joined, and the point 1 is 100% fine. Another point, another feed rate, another motion path. This is the program syntax. You will be able to see these are all different points. You can see this point 1, point 2, point 3, point 1, which means robot, when we start this program, robot will comes into this point first, P1, then it will move. When this line number 2 executes, then it come to the point number 2. After that, the line number 3 will be executed and robot will come to the point number 3. And lastly, when the line number 4 executed, that point number 1, which is the first point, robot will goes back to that point. But the feed rate and the motion path will be the different for the different motion. That one was a joint motion, and this one is the example of linear motion. What happened in a joint motion and what happened in a linear motion, I would like to tell you. In a joint motion, all joints are moved simultaneously, but in linear motion, robots moved in a linear path. To accomplish this linear path, all joints are also moved in a simultaneous manner. Here you can also see the different points, the different types of feed rate and different motion path. But this is in a linear motion and a linear coordinate system. Now I come to an example. First, this is a level 1 program for a square. For example, this is, as you can see, all these are the points, point 1, point 2, point 3, point 4, point 5. This is a level 1. The first is motion path joint. Robot will, when I start this program, robot will come to this point, point number 1. Wherever it is, but it will come to point number 1 first, P1, at a speed of feed rate of 100% or in a linear manner. As you can see, fine. Here you can see the second point, JP, joint motion, and the point number 2 at 100% fine. Robot will come from this P1 to P2. Then it will move to P2, P3, then P4, P5, then again P2. It will complete the square, and at the end of it, robot will goes back to the point number 1 from where it has started. You can see here JMP internal and call external. This is a different programming aspect. I will not go in details into this because it will vary from robot to robot. If I tell you about this is specific for this robot. That's why I would like to suggest it will be very specific for this robot. This is another program example. Here you can see different things here. These are points, these are register values, these are different things which you can be able to see into the Fanuc robot program. You can see here joint 30%, which means robot will run to it into 30% of its actual speed. When it is 100%, then as you can see here, the point 2, robot will move to point number 2 at 100 centimeter per minute. But when it is in 30%, joint 30%, then it will move the 30% of this program written value, which means the 300 centimeters per minute. When it is 100%, then the robot will move to point 2 at 100 centimeter per minute of speed. Another circular motion example. Here you can see the different points P1, P3, P1, P2, P3, P4, P5. At the beginning of this program, it's a joint motion. Robot will come to the point number 1 at a 100% feed rate in a fine path motion. From point number 1 to point number 2, it will move at 100% speed also, and from here point number 2 to point number 3 and then point number 4 in a circular path. As you can see the C here, this is indicates the circular motion. Earlier was a joint motion and this one is a circular motion, which will enable the robot to move in a circular path to accomplish in a circular job or a specified circular activity. Again, from the P5 to P, this is P4, then again it will come to P5, P5 to P2, it will come to circular path. After coming back to P2, it will goes back to P1 from this point to another path, but this one is a joint, this one will not be the circular, robot will goes back to this P1. I/O configuration. Robots end effectors have lot of actuators. For example, pneumatic cylinders to grip a job or a spot welding holder. For these actuators, we need some digital input-output, group input-output, or analog output module. By these input-output modules, robot get the feedback from the field, what is actually happening, what we have to do. After gripping a job, it will lift it up. If it not grips properly, if the input doesn't come back to the robot or the feedback doesn't comes back to the robot whether the job has been gripped properly, then it will not lift up the work. So in that case, robot stops there, and at that time the manual checking by the operator took place. You can see how many IOs can be configured in a robot, and different numbers for the different types of robots are here. For DI, you can be able to manage 32 numbers of racks, and there is a 10 numbers of slots and 34 number of stacks for these input output modules, which means we can be able to install these many amounts of actuators to get the feedback from the field. As I told you guys, each and every axis of the robot have some limitations by which it can be able to move only after beyond of these limits. These robots cannot be moved. We can also be able to edit or set this limit according to our requirement. This is the factory setting. You can see here is a minus 150 to plus 150. For example, if we need to reduce the limit, we can only reduce it, but we cannot increase it because this is the maximum value. So according to our requirement, we can be set it below of this value to accomplish a desired activity. This is the procedure to set the limit of each axis of the robot. Robots have several programs. As I told you, robots have several programs. For these programs, we need some backup systems. For example, there are several programs which are written inside the robot, and time to time we need to change this program. Time to time we need to install some different softwares, different configurations, etc. etc. For that, file backup is a very important part. Standard backup, image backup are the types of these file backups. You can see image backup. Image backups are two types. One is a flash read-only memory from, and another is a SRAM. From is a flash read-only memory, and another is a static random access memory. For flash read-only memory, it is applicable for operating system only, and as static random access memory, it is applicable for any changes done by the operator, any changes done by the field workers. That image has been taken through SRAM. And the flash read-only memory from, which is a factory setting, software and the configurations. And but the SRAM can be done at the shop floor and the work premises. This is the file backup procedure. That's from the CPU through this from and SRAM. This is the data bus. Data bus. Through this data bus, we take the file backup. Different slots are there through which we can, by the flash memory card, we can take the backup. We can restore the backup. We can install any software. We can install or configure any different type of software related activities. Here you can see this is the place where all these slots are available. Through these flash memory cards, we are able to take the backups from the robot CPU. You can see this is situated on the robot controller, and these backups can be worked on the PC. PC also, programmable device, can also be connected to the controller via these slots. Different robots and different controllers have different types of slots, but some standard slots are there which can be enable us to connect these controller with the PC. This is a procedure which is required for the troubleshooting and the backup procedure. This is the details of backup procedure, how to take backups from the robot and how to install program into the robot. Different types of backups you can see here. I'm just giving you some images. Image backup from ROM and SRAM bit for bit. Here you can see now I am come to the very important part of the robot, which is called mastering. Mastering, what is mastering? This word depicts that the mastering is a specified position of the robot. Each every axis have some specified value which is fed into the pulse encoder at, at the factory during its manufacturing. During its manufacturing, all these values are fed. These masterings can be changed according to the user requirement. These mastering can be edited according to user requirement. So the definition is mastering is an operation performed to associate the angle of each robot axis with the pulse count value supplied from the absolute pulse coder connected to the corresponding axis motor. Which means each and every axis of the robot have a servo motor. That servo motor has a specific value, which value has been taken as a mastering value. During the manufacturing of the robot, that value has been noted down and supplied to the user for their future reference and for their future activities. To be specific, mastering is an operation for obtaining the pulse count value corresponding to the zero position. If I say in a note format, then I'll have to say that mastering is a zero position of the robot. Whenever I put the values of each axis, mastering values of each axis, which means this is the zero position of the robot. Whenever we will move the robot, which is depend upon that zero value. Whenever we move the 100 millimeters from robot, that will be counted from that zero position, not from any arbitrary position. That is specified by the mastering data. When mastering should perform, when mastering is required, whenever we replace any motor, any servo motor, or remove it, if replacement or removal, at any case, we have to do the mastering. Whenever we remove or replace the pulse coder, we have to also do the mastering. And the reducer, to reduce the motor speed to the end effector, this reducer replacement activity is also required the mastering. And any kind of cable replacement and disconnection is also required mastering. Batteries for pulse count backup in the mechanical unit have gone dead. For example, batteries are dead. These batteries store the value of the mastering. Mastering values are stored, but these batteries are dead. At that scenario, we have to do the mastering again. Different types of masterings are performed. There are 5 types of mastering. One is a jig position, another is a zero position, another is a quick mastering. Fourth one is a single axis mastering, and the fifth one is the simplest one, as I told you, the mastering data. By feeding the mastering data, that mastering data entry process, we can be accomplished. The fifth type of mastering. In a jig position mastering, it is performed before shipping the robot from the factory to the user. That mastering has been performed by a jig, by placing a jig before the robot, and by the help of this mastering jig, taking the position of the robot and the jig position mastering done. In the zero position mastering, there is an eye mark in each and every axis of the robot. By placing this eye mark in a 0-0 position, we perform the zero position mastering. And in quick mastering, what we perform, this is performed at user specified position. For example, I required a different zero position than supplier, then manufacturer. Then I have to perform a quick mastering. For example, the robot have 6 axes, but only one axis having some problem with the position. At that case, I have to perform the only single axis mastering instead of all axis mastering. And I have already told you, mastering data entry process. By feeding the mastering data supplied by the manufacturer, we can be able to performing this type of mastering. This is the resetting process and the mastering process. Each and every type of mastering details are here, as I already told you. And after the mastering, several alarms will be occurred into the displayed into the HMI and the each pendant of the robot. These are the method how to reset these alarms. And you can see here you can see the PZAL or Servo 075 pulse mismatch alarm. This alarm indicates that your robot is required mastering, which means you have to perform the mastering when these type of alarm displayed on the teach pendant of the robot. When any mechanical part are replaced or changed, then we also have to perform the mastering. And that is also applicable for the motors. Whenever I change the motors, the pulse coder misses his value. In that case, I also perform the mastering. You can see here how to reset this alarm. You have to do the mastering first, then you have to able to reset these alarms. This is the mastering process, which varies from robot to robot and manufacturer to manufacturer. This is the process for the Fanuc robots. Detailed procedure for the mastering are written here, which will not be required here, but for your knowledge, mastering term and terminology and how mastering should perform and when it is required, how it is happen, it will be decided by the supplier of the robot and the type of model. But when mastering is required and what things should be in your